and far more aggressive than they were. And then you go up against a guy who's done a lot of wrestling. And you needed technique to beat that kid. So I think in 7th grade, Jack lost once or twice. In 8th grade, I don't think he lost at all. Okay, can we kill those lights, please? Let's start with the first one. Now, here's the problem. The problem is it's so darn easy that you look at it like, well, why should I bother doing it that way? I can just do this, and it's quicker and easier in my head. Well, the reason is because we're trying to set up a proper skill set to go around here. You know, I look around the room, and I see some kids working on homework, and I see some kids working on other things. That's not what you should be doing. Because what happens is, as I go through this, you're not going to get the point I want to build up. And I didn't select these problems by accident. So you can work on homeworks when we're going do it, and if I'm telling a story, you can do the homework if you wish. But when it's time to get working on the class, we don't do the do-its or the homework. Look, an equation, we've said this many, many, many times, and we're going to keep saying it. An equation is like a scale. God bless. As long as you do the same thing to both sides of the scale stays balanced. And you want to get the letter all by itself on either, whatever side of the scale it's on. I don't care if the letter's on the left or the right side. I just want to get it by itself. So the first thing I want to do is undo or get rid of this minus 1, which I do. And I have 3x equals, and 8 plus 1 is 9. And then the x is being multiplied by 3, so I need to do the opposite, which is to divide by 3. And I get x is equal to 3. Now, that is extremely routine. And if you are not doing it that way, this is not meant to be an insult. This is meant to give you a prism through which to view it. I know for a fact that the 6th graders do it this way. And there is no way an accelerated 8th grade student can't do it if a regular 6th grade student can do it. Okay, next up. -7 equals 2x plus 7. Now, the difference between the first question and this one is now I put the x's on the right side instead of the left. And it's just to let you know that you don't change a blessed thing. All you do is say to yourself, okay, that says plus 7, so I do the inverse or the opposite, which is -7. Die. 7 negatives, 7 more negatives are 14 negatives. And 2x is left on the right side. I didn't touch that. Then I divide by 2, and I get -7 equals x. And then last but not least, this guy over here, this was one that we talked about the other day that's very important. Is that 3 positive or negative? Positive 3. Is the 5x positive or negative? Negative. So this negative sign here has nothing to do with the 3. The 3 is positive, so I have to do -3. Die. Now, danger, danger, danger. When you bring this down, do not forget that that's a -5x. Right? What's on the scale stays on the scale. What was on the scale? A -5x, God bless, was what was on the scale. So you can't just go change that. It has to stay what it is. -5x it is. Now I need to divide by -5. Die. X equals -2. And that's the correct answer. Okay? Any questions? Preguntas? Now, if you look here, I summarize in the next phase of the sheet exactly what's going on. So, if you're still not with the program, these are the 3 steps. What's happening to the variable? How do I do the inverse or opposite operation? And then make sure you do the same thing to both sides. Always to both sides. So, as if I heard a echo through time from Yasmin. 3 more to do. And to do them the right way. Okay. Go ahead. Do it. Oh, what's happening to the variable? God bless. I need to do the opposite. Are you trying? First of all, you'll never hear me say that the whole year. It'll never happen.
No, you don't. No, you don't. No, not subtraction. Negative from the negative,
I wish I could go back in time and smack the person who said keep change upside the head.
No, you're subtracting the positive from the negative.
Okay. Ready?
You don't do change.
Let's take a look at the first one. I think it's pretty straightforward. This is, in my opinion, this is easier than anything you would ever see on a Regents exam. In fact, far easier. That says +4, so we do the opposite, which is -4, die. 3x is still left on its side, and, oh, I'm sorry, +4. And 12 is on this side. Then the x is being multiplied by 3, so I divide by 3. X is 4. Okay? Again, very straightforward. There's no tricks, no gimmicks. That's one of the cool things about this, is once you learn how to do this, you really don't have a problem. All right, over here it says +17. I need to do the opposite, which is -17. Die. 7 negatives, 17 negatives is 24 negatives. Equals 2x, divided by 2. -24 divided by 2, -12 is equal to x. How many people have had both questions right so far? What did you get? First one.
10, because I did the subtraction one for -7 -17.
Oh, okay. See, it's not subtraction. That's the problem. If you think of it as subtraction, you'll get it wrong frequently. It's addition. Remember, if you heard me say it, I said I have 7 negatives and 17 more negatives. Just look at everything as addition. And then the sign in front tells you whether you're adding a positive or a negative. So 7 negatives, 17 negatives, 24 negatives. Okay? That's an extremely important point. Very important point. We're beginning our work with algebra right now. And, hey, as we go through this work with algebra, you're going to learn there is no such thing as subtraction. I know that sounds insane. You've been doing it your whole life. There really isn't. If you went in a math dictionary and you looked up the definition of subtraction, it would say adding the inverse. So subtraction is addition. Now the question is, how do you perceive it? If you look at this and say, oh, that's -7 minus 17, you're welcome to. You will get the same answer. The problem is subtraction is more complicated than addition. How many people here would rather divide than multiply? How many people would rather subtract than add? So if I have a way of showing you, which I do, that this is really addition, addition's easier. You're more comfortable with it. So learn to perceive it as addition. This is 7 negatives, and that's 17 more negatives. Altogether, I have 24 negatives. Here, what kind of 8 is this?
Positive.
So now we say I'm going to -8, but it's also adding -8. It's the same exact thing. So I know our whole lives we've done 12 minus 8 is 4. That's a true statement. No problem. You can say that. But isn't it also true that 12 positives and 8 negatives are +4? Okay? Now, when it comes to this question, when I do 12 minus 8, I would probably do subtraction in my head because I can do 12 minus 8 all day long. But how many people can do -7 minus 17 in their head all day long? So being able to look at it as 7 negatives and 17 negatives make 24 negatives is a way of simplifying the problem. Okay. I did not notice, I realized this was a -4x, so I kept the negative. And now I divide by negative, die. X is -1, and that's the correct answer. Okay? Any questions? All right. So as I told you a minute ago, we're starting to work on algebra. And over the course of, I guess, about the next 15 or 18 lessons, we're going to really talk and build up your algebraic skills and get you better at that. Now, one of the algebraic skills that you have to get good at is the distributive property. Now, when I teach properties, I like to just use the English words that make a whole lot of sense that we've known our whole lives. What does the word distribute mean? English language, forget math, just English language.
Give out?
Yeah, to give out. When I think of distributing, there's always two things that come to mind. The first is a sad picture, and the second is a happy picture. The sad picture is the Great Depression. And have you heard of soup kitchens? We still have them. The Lighthouse Mission has a soup kitchen, and a few other places have soup kitchens where you literally, for people who don't have, you feed them on like Saturday and Sunday mornings. And my church has a a food pantry where families will come one day a week and we give away food. We just give it to them. Here's food, go home and have something to eat during the week. I think of the pictures in the Great Depression of soup kitchens where people had no money, and there would be lines like down Main Street in Patchogue. And then at Shorefront Park, obviously before there was a softball field built, they would have tents, and people would live in tents because they couldn't afford their houses. They'd gotten kicked out of their houses. And then to eat, they would go down, and they would just, like a cafeteria line, they would come through. And they'd just take 2 big ladlefuls of soup and say, here, you got something to eat. They were distributing food to the needy. So that's the sad picture of distributing. Every single person that went through that line got something to eat. No one was turned away. The other thing I think of is Christmas. And I think of when my sons were young, and we would buy Christmas presents, and they would read the name on the tag and then distribute the present to whoever it was. Yes?
Hold up. You bought the Christmas presents, not Santa?
I have to tell you, Santa and I share a lot in common. So much. You know, it's funny you would say that. I have these 2 nephews, and they're just a little innocent. Innocent. It means that, yeah, I would say there's no way they knew who Santa was before 6th grade. Or they didn't know Santa was fake before 6th grade.
So he is fake?
And I'm not sure until 8th grade. Like, they used to get really excited and go on the website that showed where he was at any point in time. You know that website? Like it's Noah or whatever? There really is a website that does that. And they would be like bouncing with this energy. He's almost here. He's almost here. And I'm going, oh. Now, me, on the other hand, when I was a little kid, my Uncle Paul came over one day to play Santa Claus. And all I know is I was young enough that I could sit on his lap. So however young that is, 3, 4, 5, 6, whatever. I was a big kid, so it wasn't 8. And I just remember going, you're not Santa, you're Uncle Paul, reaching up and pulling his beard off. So, you know, he couldn't get anything past me. All right, so the big thing we want to discuss here is distributing. And to distribute means to give out, whether you're distributing Christmas presents and giving them out, or if you're distributing food to people who wouldn't have anything to eat otherwise. This 3 is what's going to be distributed. It's outside the parentheses. And sometimes it helps to draw 2 little hoops like that. And what it does is it reminds you that you have to distribute and multiply across. So, what's 3 times 4n? 12n. And 3 times -5. Now this again is very careful that you look at this as a -5. What's 3 times -5? -15. And that's my answer. 12n minus 15. Now, do you remember what we said was the rule if you multiply by a negative? Right, you have to change the sign. All right, so try letter H. Let's see how you do. Don't do the next one, just do H. Okay, now, whenever you multiply or divide by a negative, you change that sign. What does it mean to negate in the English language? To what? Okay, girls, just between us girls, listen, you got a boyfriend, all right? Your boyfriend does something nice. He buys you flowers, gets you a little thing of candy, trail mix, all right? Now, you think he's having a great day. You know how boyfriends just have this way of saying the dumbest things?
Yeah.
And it immediately, like, just sets you off, like. Now, if he's doing all these great things and he's putting you in a wonderful mood, and then he says one of those things that only boyfriends are capable of saying, he has negated all of his good efforts. When you negate, what do? You make it its opposite. If you were doing really good, what does it become? Really bad. If you were doing really bad and you negate it, hey, now she starts to smile, like if you've been fighting like crazy and you go to Carvel and you go get a really, really good ice cream and you bring it home with a teddy bear, you have negated the bad thing. So things are good. So, Kirsten, I don't know when you're gonna get a boyfriend, but when you do, make sure you send him to me, because I'll make sure he keeps you happy. Now, all right, ready? -5 times x. When I multiply here, look, girls, I'm multiplying by the 5, but I'm also multiplying by the negative. Multiplying by the 5, that gives me the 5x. But when multiplying by a negative, I have to change it. See, it was a positive, but when I multiply by a negative, I make it a negative. So -5 times x is -5x. I'm both multiplying by the 5 and I'm negating. When I do -5 times 4, the 5 times 4 would give me 20. But that's a positive 4. When I multiply that by a negative, it negates a positive. If you negate a positive, what do you get? Negative. So the answer is -5x minus 20. So to negate means to switch its sign. Positive to negative, negative to positive. Try the next one. Okay. Now, this -2, girls, this -2 is being multiplied by a positive 3. So the 2 times 3 part would be 6, but it was positive. It's now being negated. What is it? -6. Now this 4n, when I multiply it by 2, it's pretty obvious I'm going to get 8n, right? But is the 8n going to be positive or negative? Positive, because I'm negating that. So it's -6 plus 8n. All right. Any questions about distributing? Yes.
Can you just explain how it turns into an addition?
Well, there's two ways. The way I hate that you may have been raised on, so you may go with it, is a negative times a negative is a positive. I hate that way, because in addition rules it doesn't work. I just look at it as this way. I'm multiplying by the 2 and I'm negating. So when I multiply the 2, I clearly get the 8n part. And to negate it means I have to take whatever that sign was and negate it. So it has to become its opposite sign. All right? Now, the next thing, putting it all together. What do you think we would do for letter J? How do you think you solve that equation?
You distribute it properly and then you do the
The rest of the steps, the normal steps. Go ahead. Okay, so I distribute the 2, and that gives me 2x minus 14, right? And again, looking up here, right? 2x minus 14, because 2 times x is 2x, 2 times a -7 is -14, equals 22. Yasmin, what's my next step?
So you add 14.
Yep, always to both sides. Die. 2x is 36. Sam, next step. Beautiful. Divide by 2. X is 18. Any questions on that? How many people got them right? How many people actually did the work the right way? Very good. I wasn't worried about your work. I was worried about her work. Okay, next 2. Do it. Make sure when you multiply by the 4 here, you're both multiplying by the 4 and negating, right? I did them on the board. You can take a peek and see if you got the same answers. If you did, odds are that you got it right. Any questions? Sam?
How is that minus?
How what?
How is that 4?
How what? Did you get negative 32?
No.
Well, now we know what the problem is.
How did you get minus 12 and minus 5?
What's 12 negatives and 20 negatives?
Why are you subtracting?
I'm adding. What's 12 negatives and 20 negatives?
Oh. I know what I did wrong, but I still don't get why.
Well, why don't you correct what you did wrong and then see if from that point forward it leads to my answer.
Yeah, but I don't know why you had to make it plus 20. If the sign is, I get it now, I get it now.
I feel like a therapist. I don't really say much. I just keep asking her how she feels about that. And eventually she figures it out for herself. Okay, any other questions? All right, so I want to go and I want to look at the three things that we have spoken about so far. Oh, hold it. This one. No, this one. No, this one. Hold it. There we go. Okay. If I remember right, and frankly, I have so many classes I get confused at times. We have handled 4 things. One looks like this. 3n minus 1 equals 8, right? What would be the first step, everybody? Plus 1. What would be the second step?
Add it to 8.
No, divide by 3. Next. What if I gave you one that looked like this? What would you do? Distribute and then add the 3 and so on and so forth. Okay. What if I gave you one that looked like this? What would be my first step there?
Put the variable on one side.
Yeah, letters on one side, numbers on the other. This is an opposite side situation, so you would do the opposite operation. Remember, same side, opposite side? And then what if I gave you one that looked like this? What would you do there? Add them because they're on the same side. So what I'm looking for you to know and realize is that this is a same side situation. This is an opposite side situation. And this is what we discussed. I would call these standard two-steppers. They're pretty straightforward. Okay? All right. So tomorrow we will continue to roar forward with more understandings of algebra. Yes. I'm sorry, what was that? Your next test, I want to say,